Yes. In this video, we are going to discuss about graphical representations of the unit step signal. So first of all, understand the definition of the unit step signal, and similarly we can understand the u of minus t minus u of t minus u of minus t u of t plus 2 u of t minus 2 like that. So similarly understand the remaining graphical representations of the unit step signal. So this is very important, and in signals and systems, Fourier transform, Laplace transform, in exam point of view, they are asking find out the Fourier transform of e power minus at u of t and the Fourier transform of e power minus at u of minus t. Find out the Fourier transform of e power minus 2t u of 2t. Find out the Fourier transform of e power minus 3t u of t by 2. So, in similarly in Laplace transform they are asking find out the Fourier transform of find out the Laplace transform of e power minus at u of t, Laplace transform of e power minus at u of minus t, Laplace transform of e power minus 2t u of 2t. So like that. So because of that, first understand the u of t, u of minus t, u of t plus 2, u of t minus 2 like that. First understand that signals. And first one is u of t. U of t is an unit step function or unit step signal. So the definition of unit step signal is u of t is equal to 1 for t greater than or equal to 0. So t greater than or equal to 0 mean the range of the t is equal to 0 to infinity. The range of the t is equal to 0 to infinity. So for t is equal to 0 to infinity, the strength of the unit step signal is 1. The strength of the unit step signal is 1. And t less than 0. T less than 0 mean minus 1 to minus infinity, the strength of the signal is 0. So 0 mean on the x-axis. So this is the graphical representation of the unit step signal. And next one is u of minus t. So according to the definition of the unit step signal, this is the definition of the unit step signal. So u of minus t is equal to 1 for minus t greater than or equal to 0. Now we are multiplying on both sides by negative sign. So when we are multiplying, taking the negative sign on both sides, LHS side minus into minus plus. So when you have to applying the negative sign on both sides, this greater than or equal to will be converted to less than or equal to minus 0. So minus 0 or plus 0, whatever. So that is t less than or equal to 0. So what is the meaning of the t less than or equal to 0? The range of the t is minus infinity to 0. So this is minus infinity and this is 0. So minus infinity to 0, the strength of the signal is 1. So this is the graphical representation of the u of minus t. And similarly, for t greater than 0, the strength of the signal is 0. So that is u of minus t and u of minus t definition and graphical representation of u of minus t. And next one is minus u of t. So what is the definition of the unit step signal? U of t is equal to 1, t greater than or equal to 0. And the graphical representation of the u of t is so this is the graphical representation of the u of t signal. So now here minus u of t. So minus u of t and this is positive y-axis and this is negative y-axis. So minus u of t. So folding u of t signal about the horizontal axis. Folding the u of t signal about the horizontal axis. We get minus u of t. So this is the graphical representation of the minus u of t. Next one is minus u of minus t. So the graphical representation of the unit step signal is, so this is the graphical representation of the unit step signal u of t and u of minus t. So u of minus t mean folding this signal about the vertical axis. About the vertical axis. U of minus t already explained. So using the definition of u of minus t, u of minus t is equal to 1 for minus t greater than or equal to 0. So minus t greater than or equal to 0 mean t less than or equal to 0. So t less than or equal to 0 mean minus infinity to 0. So minus infinity to 0, the strength of the signal is 1 and greater than 0, 0. So this is a graphical representation of the u of minus t. So now here we want to find out minus u of minus t, and this is positive y-axis plus u of minus t, and this is negative y-axis minus u of minus t. We can find out the minus u of minus t folding the signal u of minus t about the horizontal axis, and this is the horizontal axis. About the horizontal axis folding this signal, we get the graphical representation of and this is the graphical representation of minus u of minus t. Next, u of t plus 2. Using the definition of the unit step signal, u of t plus 2 is equal to u of t plus 2 is equal to 1 or t plus 2 greater than or equal to 0. So what is the basic definition of the unit step signal? U of t is equal to 1, t greater than or equal to 0. This is the basic definition. So now here we want to find out u of t plus 2. Using this definition, u of t plus 2 is equal to 1 or t plus 2 greater than or equal to 0. So this 2 is going to the RHS side. We have minus 2. So that is t greater than or equal to minus 2. So t greater than or equal to minus 2. So the range of the t is minus infinity to plus infinity. So negative x-axis. The negative x-axis time values are minus 1, minus 2, minus 3 like that. So now we are greater than or equal to minus 2 mean, so minus 2 to plus infinity, minus 2 to plus infinity. So this is the graphical representation of u of t plus 2. The signal u of t signal will be shifted towards left side by 2 times. So for t greater than or equal to minus 2, u of t plus 2 is equal to 1 for t greater than or equal to minus 2, and this is the graphical representation. And next one is u of t minus 2. So similarly, using the definition of unit step signal, u of t is equal to 1 or t greater than or equal to 0, and this is the basic expression, basic definition. So now here we want to find out u of t minus 2. Using this definition, u of t minus 2 is equal to 1 or t minus 2 greater than or equal to 0. So this minus 2 is going to the RHS side. We have t greater than or equal to 2. So t greater than or equal to 2. So now the t value is positive value, and this is a positive time axis, and plus t is equal to 1, t is equal to 2, t is equal to 3, like that up to t is equal to plus infinity. T greater than or equal to 2 mean 2 to infinity. The step signal value is 1. And this is the graphical representation of the u of t minus 2. U of t minus 2 is equal to 1 for t greater than or equal to 2. 2 to infinity, the step value is 1. And t less than 2, 0. So 0 means this is the t less than. And next one is u of minus 2 plus 2. In a similar manner, using the definition of the unit step signal, u of t is equal to 1 or t greater than or equal to 0. This is the definition. Now here the signal is u of minus t plus 2 is equal to 1 for minus t plus 2 greater than or equal to 0. So this minus t is going to the RHS side. We have t greater than or equal to t. So 2 greater than or equal to t or t less than or equal to 2. Both are the same. So for t less than or equal to 2, t less than or equal to t mean the range of the t is minus infinity to 2. So minus infinity to 2, the strength of the signal is 1. Now the time t value is positive value, that is positive x-axis, and this is t is equal to 2. T less than or equal to 2, the strength of the signal is 1. So this is the graphical representation of u of minus t plus 2. And t greater than 2, 0. 0 mean on the x-axis. Next, u of minus 2 minus u of minus t minus 2. So in a similar manner, using the definition of the unit step signal, u of minus t minus 2 is equal to 1 or minus t minus 2 greater than or equal to 0. This minus t is going to the RHS side. We have minus t greater than or equal to, or otherwise, so this minus t is going to the RHS side. We have minus 2 greater than or equal to t. So minus t greater than or equal to t mean t less than or equal to minus 2. So t less than or equal to minus 2 mean the range of the t is minus infinity to minus 2. Now the t value is minus 2. So negative x-axis minus 2. So less than or equal to minus 2. So minus infinity to minus 2. The strength of the signal is 1. And this is the graphical representation of the u of minus t minus 2. The next one is u of 2t. In a similar manner, u of 2t. So this is the definition of the unit step signal. So using that definition, u of 2t is equal to u of 2t is equal to 1 or 2t greater than or equal to 0. So this 2 is going to the RHS side. We have t greater than or equal to 0 by 2. So 0 by 2 is 0. So t greater than or equal to 0. So for t greater than or equal to 0, u of 2t is equal to 1. U of 2t is equal to 1. And t less than 0. T less than 0 means minus infinity to 0. The strength of the signal is 0. Next, u of t by 2. In the same manner, using the definition of the unit step signal, u of t by 2. So u of t by 2 is equal to 1 or t by 2 greater than or equal to 0. So this 2 is going to the RHS side. We have 0 into 2. 0 into 2 is 0. So t greater than or equal to 0. For t greater than or equal to 0, u of t by 2 is equal to 1. And t less than 0, u of t by 2 is equal to 0. The next one is u square of t. So u square of t. So u of t whole square is written as u of t into u of t. So u of t is the unit step signal. And this is the definition of the unit step signal. U of t is equal to 1 or t greater than or equal to 0. So multiplying the strength of the magnitude values of the unit step signal. U of t is equal to 1 into U of t is equal to 1. 1 into 1, 1. So, U square of t is equal to 1 for t greater than or equal to 0. This is the graphical representation of U square of t. And t less than 0, U of t is equal to 0. The next one is, so draw the graphical representation of U of t plus 2 minus U of t minus 2. So the graphical representation of U of t plus 2 and U of t minus 2 already explained in this video. So what is U of t plus 2? So U of t plus 2 means the signal U of t will be shifted towards left by 2 times. So U of t plus 2, U of t plus 2 is equal to 1 for t greater than or equal to minus 2. So for t greater than or equal to minus 2, so this is the graphical representation of U of t plus 2. And U of t minus 2 is equal to 1 for t greater than or equal to 2. And this is the graphical representation of U of t minus 2. And U of t minus 2 U of t plus 2 minus U of t minus 2. So now here in this graphical representation, 2 to infinity, the strength of the signal is 1. So now here in this graphical representation, t is equal to minus 2 to infinity, the strength of the signal is 1. Okay, subtracting U of t minus 2 signal from U of t plus 2. So now here in this minus 2 to plus infinity, 2 to infinity is also there. 2 to infinity is there. So 2 to infinity and 2 to infinity is cancelled. So what is the remaining value of the t? The remaining value of t is equal to minus 2 to plus 2. So the graphical representation of U of t plus 2 minus U of t minus 2 is, so between minus 2 to plus 2. This is the graphical representation of U of t plus 2 minus U of t minus. So once again I will explain and another way. And this is the graphical representation of U of t plus 2, and the graphical representation of U of t minus 2 is, this is the graphical representation of U of minus 2. So now here, and t greater than or equal to minus 2, t greater than or equal to minus 2, and t greater than or equal to minus 2, and t greater than or equal to plus 2, this is the common area. So now with the minus, so because of that, so this portion is cancelled. What is the remaining portion between minus 2 to plus 2? That one is and 2 U of t. So now here, find out the Fourier transform of 2 into U of t. So using the definition of the unit step signal, U of t is equal to 1. U of t is equal to 1 for t greater than or equal to 0. And 2 into U of t. So U of t, strength of the signal is 1. So 2 into 1. So 2 into 1. 2 into 1 is, so 2 into U of t is 2 for t greater than or equal to 0. So t greater than or equal to 0 means 0 to infinity to u of t is equal to 2. The strength of the signal is 2. And less than 0, 0. So this is the graphical representation of 2 into u of t.